Today, let's talk about a charming creature, often spoken of yet distant from our daily lives. This distance isn't just geographical but temporal and storied, tracing back to eras long past. They are the penguins. Why are they considered distant? Because they are survivors from a nuclear winter 65 million years ago, the last dinosaurs. Their black coats do little to slim down their rotund figures. Watching them waddle in groups through the Antarctic, glaciers, and seas, they exude an air of endearing charm amidst the cold, a testament to their resilience and rich narratives that we often overlook. In the eyes of scientists, penguins are unique flyers, navigating the aquatic realms like no other bird. They propel themselves by flapping their wings, contrasting seals, which undulate their bodies to move through water. This aquatic flight highlights their bird-like essence, especially as they breach the water's surface. Penguins are packed with fat, coated in smooth, oily feathers, and can release tiny bubbles to reduce drag, enabling them to fly through water as birds do in the air. They can reach speeds up to 36 kilometers per hour, dive up to 565 meters deep, and hold their breath for over an hour, rivaling whales in aquatic prowess. After delving into their swimming capabilities, let's explore their walking. Their waddling, endearingly clumsy gait is memorable. This waddle isn't due to a lack of knees. Penguins possess long legs hidden beneath layers of fat. So although they appear to stand upright, they're essentially squat walking, adding to their charm. In the year 2000, researchers made an unexpected discovery while studying penguins. Their walking efficiency surpasses that of humans. It's widely recognized that few bipedal animals can outpace humans, thanks to our walking mechanics that efficiently recycle gravity. As we move forward, our bodies lean, harnessing gravity to propel us and conserve muscular effort. While upright gorillas only manage a 35% efficiency in gravity recycling, bears fall below 10%, chickens hit 60%, and humans boast an impressive 65%, leaving these creatures far behind. However, penguins break the mold with a staggering 80% efficiency, dethroning humans in the contest of upright locomotion. These adorable little fat geese have outpaced us, thanks to their unique mode of walking. What gives these chubby birds the edge? Scientists suggest that adversity has turned into advantage. Walking in a squatting posture means a lower center of gravity, making it hard to leverage gravity and increasingly tiring. However, by not only leaning forward but also swaying side to side, penguins have adopted an endearing yet energy-efficient manner of walking. This peculiar gait might also be related to their fat, which serves as insulation against the cold, prompting penguins to hide their legs within thick layers of fat. But why then are their feet exposed? Aren't they cold? Scientists have observed that penguins can withstand temperatures as low as -117 degrees Celsius without their feet freezing, thanks to a sophisticated structure evolved on their ankles, a counter-current heat exchange system. This system intricately entwines blood vessels at the ankle, ensuring that the warm blood flowing to the feet and the cold blood returning do not cause a significant drop in temperature. Without this mechanism, the blood could cool drastically from 37 degrees to as low as 13 degrees due to the feet's large, thin surface area acting like a radiator. To maintain a stable body temperature, a lot of energy would be needed to reheat the blood to 37 degrees. The body couldn't afford to expend so much energy on just the feet, risking them freezing solid. However, with this counter-current heat exchange system, the incoming warm blood cools down and the outgoing cold blood warms up, reducing the temperature difference to just about 1 degree. This makes it much easier to heat and maintains the feet's temperature within 5 degrees, preventing freezing. Such a simple yet effective adaptation solves many problems, showcasing nature's marvel. It wasn't until the 14th century that alchemists first conceptualized structures for counter-current exchange. Yet this mechanism has possibly existed in homothermic animals for hundreds of millions of years, leading to the saying that all advanced technology is inspired by biomimicry. The emperor penguin, the largest of its kind on Earth, can grow up to 1.2 meters tall and resides in the southernmost reaches of our planet. Each year, they embark on a journey deep into the Antarctic hinterland, traversing over 100 kilometers to endure the chilling embrace of -60 degrees Celsius, huddling together for warmth and nurturing their chicks. They even establish nurseries. In April, they form vast processions, departing the coast to march into the interior of Antarctica. By June, they reach their breeding grounds inland, often covering distances exceeding 150 kilometers. They utilize a unique method of belly sliding alongside their short-legged march to conserve energy. Upon arrival, a month-long courtship ensues, leading to monogamous pairings for the season. However, these relationships are annually renegotiated, with partners swapping each year. This mating dance can lead to confrontations if singles intrude, resulting in brawls until all solo participants are left to return alone to the sea. In the harsh environment of Antarctica, emperor penguins face few predators, yet during egg laying, any creature can become a threat. Penguin eggs lack any insulation against the cold. Exposure for mere minutes or contact with the ground can freeze them. Male penguins are equipped with a brood pouch above their feet for incubation. By August, the females lay their large eggs, depleting a significant portion of their nutritional reserves, leading to a weight loss of a quarter. As the sun vanishes, heralding the polar night and winter, females entrust the eggs to the males and hasten back to the sea for nourishment. Meanwhile, the males endure over 2 months without food or water, braving the winter. The females gorge themselves on fish before swiftly belly sliding back to their mates and offspring, identified by scent and call. They regurgitate a milk-like substance to feed them. This round trip can sometimes span 6 months. Typically, male penguins endure the harsh winds for over 60 days awaiting the return of their mates. In one extreme case, a penguin waited 115 days, losing 53% of his body weight before his partner finally returned. Often, the chicks hatch before the mothers come back. Penguin fathers then cradle the newborns in their brood pouch, secreting a milk-like substance from their beaks to nourish them. When strong winds blow, the fathers huddle together, forming a large circle to share warmth. The temperature at the circle's center can reach up to 30 degrees Celsius, so they shuffle from the inside out and vice versa to avoid overheating. This dynamic rotation ensures that those on the perimeter don't freeze. With the sun's return, the penguins head back to the sea. If the chicks haven't fully grown, they're placed in nurseries. These are spontaneously formed circles of adult penguins that protect the young from the cold. As the chicks mature, their plumage turns brown before they molt into their adult feathers. Apart from the emperor penguin, Antarctica is also home to the Adelie penguin, smaller in size and with diminutive eyes, not even half the size of its larger cousin. About a century ago, a British doctor named George Murray Levick ventured to Antarctica and was charmed by these little gentlemen in their tuxedo-like plumage. He noted their monogamous relationships and harmonious family units, contrasting them with other animals. Levick wrote several papers that quickly endeared these creatures to the British public. However, after a while, Levick ceased sending information about the penguins back home, and upon his return to Britain, he seldom spoke of them again. It wasn't until a century later that Levick's notes on penguins were disclosed, revealing a rather rambunctious side to these creatures. Initially praised as gentlemen, deeper observations painted them as rogues devoid of any scruples, prompting Levick to pen his findings in Greek to shield the innocent from these unsettling truths. The Adelie penguins, in preparation for egg-laying, seek out ice-free ground and build nests from stones, making these pebbles as valuable as currency amongst them. This incites their kleptomaniac tendencies. For instance, a male penguin might stealthily steal stones from a neighbor's nest while they're away. This tit-for-tat behavior often leads to none being able to properly construct a nest. Faced with the impending hatching, males may expel their mates to scavenge for more stones, while some females resort to pecking their partners or flirting with the neighbor for more nesting materials. Infidelity and seductive glances come at a cost, usually paid in stones. The notion of monogamy seems only skin-deep among these penguins, revealing a complexity in their relationships. Some bold females snatch stones the moment another penguin is distracted, causing a cacophony of squawks not for revenge but to scold their partners, adding to the drama. In breeding seasons when the snow hasn't melted, Adelie penguins resort to defecating around them to uncover stones, utilizing a pressure at least 8 times stronger than humans to achieve this, leaving the area fragrantly marked. When fishing, penguins might kick their comrades into the sea first to fend off potential seal attacks, adopting a sacrifice-the-buddy strategy that underscores their survival instincts, albeit in a less than noble fashion. Levick's notes shattered his view of the penguin world, revealing a reality far removed from the innocuous creatures many imagined. He deemed such observations unsuitable for the public of his time, a stark contrast to the seemingly gentle nature attributed to penguins, humorously highlighting their absence in the Arctic, a domain free of penguins, not due to fearsome polar bears but simply because penguins inhabit the southern hemisphere. Yet, in a surprising twist during the summer of 2002, scientists in Alaska captured a Humboldt penguin, a species native near the Antarctic realms of Peru, having crossed equatorial divides to the Arctic proximity of Alaska. This event led to inquiries with zoos within a 500-kilometer radius, suspecting an escapee, only to find no Humboldt penguins missing from captivity. The theory then emerged that this penguin might have fled from a Peruvian fishing vessel, speculated to have been kept as a pet by the crew. The puzzle intensified with the capture of another Humboldt penguin in Alaska in 2012 and subsequent sightings in Tokyo Bay, suggesting a remarkable adaptability among penguins. Penguins are found not only in Antarctica but also in Africa, Australia, New Zealand, and even near the equator, challenging preconceived notions of their habitat restrictions and survival skills reminiscent of the Madagascar movie's covert operatives. With 21 species identified and 2 extinct, 19 penguin species thrive today, cherished by humanity, which has grown increasingly conscious of wildlife conservation since first encountering these creatures in Antarctica over a century ago. However, scientists warn of potential extinction for the emperor penguin by 2100, attributing the threat not to a lack of animal conservation, but to environmental changes beyond human control. Events like a significant iceberg break in 2010, leading to nearly 150 penguin deaths, underscore the fragile balance of their ecosystems, suggesting the once dominant penguin empire might face its twilight in the Anthropocene, our current geological era.